Now, after the equation of trajectory, we will have to find out the time of flight of the projectile, the maximum height attained by the projectile, and the horizontal range attained by the projectile. So we know from the equation of trajectory, if you throw any object into space, then that object or the projectile will follow a parabolic path. So this is the path in which the projectile will follow. Now the time of flight is the time taken for a projectile to cover this distance from this position to this position. That is the time from the starting position till it reach the ground. So that is the time of flight, and the maximum height is this height here. This will be the maximum height attained by the projectile. So this is denoted by h and is the maximum height from the ground attained by the projectile, and the distance from the starting position to the ground to the final position, this distance is known as the horizontal range, and that is denoted by r. So here we'll have to find out the expression for r, h, and the time of flight, which is denoted by t. Okay, time taken to cover this distance, r. So that time of flight can be found out by using one of the equations of motion. And the equation of motion, which we'll have to use to find out the time of flight, the expression for time of flight is Vy is equal to Uy plus Ayt. So this is the one of the equation of motion, and this is taken along the y-axis. Vy is the final velocity, Uy is the initial velocity starting from this position. This will be your Uy, the velocity in this direction. Remember, the velocity, initial velocity is in this direction. We'll have to split it into Uy and Ux. So this Uy is in this direction. Now Vy is the velocity at any point of time, in the path of the projectile. Now if the projectile reaches this position, then at this position the time will be half of this time period. So from this position to this, the time taken is half of the time of flight, and at the maximum height attained, the velocity Vy, the velocity will become 0. Okay, see, if you throw any object upwards, at some point of time it will stop, then it will come back down. So here also, this is the point where the object stops and then comes back down. So here the velocity decrease till it reaches this Vy to be equal to 0. Then it comes back down with an increasing velocity in the negative direction of y, in this direction. Hence here, at t is equal to t by 2, Vy is equal to 0. So here we'll have to put this condition. At t is equal to t by 2, Vy is equal to 0. So here if you put this one here, you'll get 0 is equal to Uy, then minus g, because the acceleration along the y-axis is always negative and is denoted by g. Then we have t to be equal to t by 2. Now here, remember, this t is the time of flight. So here we bring this term this side, we'll have g t by 2, and this is equal to Uy. Now Uy, this is from equation 2. When we resolve the vector to two component, Uy is equal to U sine theta, and this g, it comes down. So here g comes to the denominator, and this 2. So here we have t to be equal to 2u sine theta divided by g. So this is the expression for the time of flight, the time taken to travel the distance r. Now we'll have to find out the expression for the maximum height attained, that is h. And to obtain the expression for this maximum height, I'll write maximum height attained, by the projectile. Okay. This is denoted by h. So here to obtain this expression for the maximum height, again we'll have to make use of the equations of motion. And since this h is the distance in the y-axis, we'll have to use this equation. Y is equal to uyt, then plus half ay t square. Then we know that at t is equal to t half, this y is equal to h. So I'll drop this one off. So this is the y-axis. So at this point it has some value. At this point, if the projectile reached this point, it has some value. If it reached this point, y has some value. If it reached this point, then this y, okay, this is the y here, this is equal to h. So at t is equal to t by 2, your y, this one, is equal to h. So here we'll have to put that value again here at t is equal to t half, y is equal to h. So putting the value, we have h is equal to, now uy we know it's u sine theta, t is equal to t by half, then plus this one half, then minus g, then instead of this you put t square by 4. Then this minus, it comes here. Minus will come there. Then for this expression, we'll have to eliminate this t. So we know that t is the time of flight, and that is equal to 2u sine theta, or t by 2 is equal to u sine theta. That we have done just now. So here u sine theta, instead of t by 2, I'll write another u sine theta by g. U sine theta divided by g. And minus half. Again here also, I can write this one as, instead of t by 4, I can write it as t by 2 holding square. So here minus g, and t by 2 is u sine theta by g. So we have u square sine square theta by g square. Okay, because we have the square here, so we're taking the square also. So g and this square cancel. Now this u sine theta into u sine theta, this will give you, if you multiply this, you get u square sine square theta. So here we have u square sine squared by g minus half u square sine square by g. So here we have 1 minus half. Okay, so you can take common this u square sine square theta by g. Upon taking this common, you'll get, okay, you take this common. So So you take u square, you have 1 minus half. And 1 minus half, this is equal to half. So you get half of u square sine square theta by g. So this will be the expression for the maximum height attained. Next we are going to find the range of the projectile, the horizontal range R of the projectile. So that will be number 4, and this will be the horizontal range of the projectile. This is denoted by R. Again, here we have to use one of the equations of motion, and this is along the x-axis. So we'll use this equation of motion. Your x is equal to ux t plus half ax t square. Now, I've told you before, ax is equal to 0. There's no acceleration along the x-axis. So here, this term will be equal to 0. So we are going to use this formula only. So x is equal to ux into t. Now, again here, what is the time taken to cover this distance r? The time taken is capital T. So here at t is equal to this capital T, x here will be equal to r. So here you have to write at t is equal to capital T, your x will be equal to r. So putting in the equation, you have r is equal to, now ux you have found this by resolution of vector u cos theta, then capital T. So this will be the horizontal range of the projectile, and here you'll have to again eliminate this. So what you have is r, and this is equal to u cos theta, then we have 2u sine theta by g, and then you have u into u is u square, then we have 2, I'll write first sine theta, then I'll write cos theta, then divided by g. Now this formula 2 sine theta cos theta, it is actually equal to this one. This is actually equal to sine 2 theta. Okay, this is a trigonometry formula. So 2 sine theta into cos theta is equal to sine 2 theta. So instead of this one, I'll put this sine 2 theta. So here we have sine 2 theta by g. So this would be the horizontal range of the projectile, expression for the horizontal range of the projectile. So those are the expressions which are needed to be obtained. One is the equation of the trajectory. Number 2 is the time of flight. Number 3 is the maximum height attained by the projectile. And number 4 is the horizontal range of the projectile.